here are some solutions to the practice problems for the exam. I'm just going to skip through and make sure I do some of each. Don't forget that on this posted version of the handout, the fourth page has answers to all the problems on it, so you can check your answers. In the first problem, we're reading graphs, and so we're asked questions about f and f inverse. Keep in mind that the graph here is the graph f that's shown. So, for example, f of 6 means on the f graph, that tells us the name of the graph, so that's that guy. The input's going to be 6, so the input is the x-coordinate, and it's asking us what the y-coordinate is. So in this case, it's -4. And so essentially that's because the point 6, -4 is on the graph of f. So this statement is the same as saying that 6, -4 is on the graph of f, which is what we can see. Now we can, to answer a question about f inverse, we can draw a sketch of f inverse by drawing the key points, and so the easiest thing to do is to, and you can see down in number 2 we have to do this anyway, so you might want to go ahead and do it. But these places where the graph changes direction are very easy points to plot for f inverse, and then you can just sort of connect the dots. On the other hand, if you wanted to do it directly, so you ask yourself, what is f inverse of -3, and I write it as an equation, then we can sort of think of this the same way we were doing our logarithm and exponential problems, where we say that a statement, an equation about f inverse is equivalent to an equation about f, where the inputs and outputs are reversed. This is exactly why we do this switching thing with the logarithm and exponential functions, because they're inverses of each other. So this question, f of what equals -3, since that's a question about f, and that's the graph we have, we can interpret this question on this graph that's already there and answer it. So this is saying, when is the output of f -3, which is when the y-coordinate is -3. So here's a point right here where there's an output of -3, and that happens when the input is 2. And so I can cross this out and say f of 2 is -3, so therefore f of -3 is 2. And that would be the right answer. Now, if I'm going to have to plot these anyway, that would be one of the first ones I had plotted. So let me just plot a few, thinking about f number 2 here, to make sure we're doing it right. So, for example, the point 6, -4, when you reverse the coordinates, becomes -4, 6, which is up here. And so that's sort of like the mirror image of the point that we started with across this line. This is the imaginary line where the y and x coordinates are equal to each other, and that's sort of the mirror for what we're doing. So the point 2, -3, when you switch it, becomes -3, 2. So that's here. So that's part of so this part of my f inverse graph corresponds to this. So this is becoming f inverse. Let's just plot one more point so we can see it. So the next point along here will be this point 0, 1, and so when we flip it, that becomes the point 1, 0. So that's here. So we'd have, well, that's pretty bad. Yeah, it's the best I can do. So we can just follow the points 1 to 9 and switch their coordinates, and then plot those and connect them, and that'll be our graph of f inverse. And after you've done that, then you could just read these off. This is not hard at all once you've done that. But if your drawing isn't great, like mine, it's not so great. Reading off this crappy graph that you drew is kind of hard, but doing this switching idea is pretty easy, and the switching idea is what's making the work for logarithms and exponents work. So that's typically the way that I would do it. Okay, so at number 3, there was a problem like this on one of the worksheets, so you can go look at a video for that to see more, see another example if you want to. But I'll just pick one of these. So let's do this one. Drawing this is not hard. We have, it goes to the point 0, 4, and goes to the point 3, 3, 0, looks like. So I'm just plotting a couple of points that are easy to plug in. So g of 0 is 4 and g of 3 is 0. So this is what the graph of g of x looks like. And if I want to draw a picture of g inverse, because you only need 2 points to determine a line, I could just switch those 2 points. So g inverse is going to go through 0, 3, and 4, 0, because those are the mirror images of 0, 4, and 3, 0. And, oops. So g inverse is going to look kind of like that by just drawing 2 points on it. So if you can plot 2 points on g to draw it, you can draw 2 points on g inverse and draw it. You might want to draw, plot like 3 points on each just to make sure that you're not making an arithmetic mistake, because if you draw 3 points and they don't look like they fall in a line, then probably one of them is wrong. In order to find the algebraic formula for this, remember that our process went like this. We first wanted the equation to be written in terms of y and x, because our understanding of inverse is that it's going to switch the role of the x and y coordinate. And so we want the notation that suggests how the x and y coordinates are related. So the second thing is that we solve this for x. So if I bring the 4/3 x to the left and put the y on the right, and then multiply everything by 3/4, I'll have x equals 3 minus 3/4 y. So all I'm doing is just doing normal algebra, trying to isolate the x. And then the third step was to switch the x and the y. And this is the step that actually forms the inverse. The other steps just rewrote the equation, but this forms the inverse. And so this is the equation of this dashed line up here. So that would be my equation for the my algebra expression for for g inverse of x. On this page, first we see some problems with composition. This is largely just notation, so don't forget that the funky G0F or OF thing is just telling us that we need to nest the functions. And so this is the same as saying G of f of 2. We know we need to work inside the parentheses out. There's no other way to do it. So we just go up and look at what f of 2 is. Here's f. So f of 2 is 2 over 2 minus 1. So 2 over 1 is 2. So it just so happens that f of 2 is equal to 2. And then we look at the g rule, and the g says that g of x should be 2x plus 1. And so when you put 2 in, you get 5. Similarly, here, this would be f of g of negative 2. G of negative 2, according to the formula, is 2 times negative 2 plus 1, whatever that is, negative 3. So I have f of negative 3. So inside the parentheses, that g of negative 2 is really the same thing as just negative 3. And then f of negative 3 is negative 3 over negative 4, which is just 3/4. In number 6, this is an application problem, but it's not really a word problem. It's just giving you a formula and then asking you a question about the formula. So don't get overwhelmed with the fact that it's describing it in words. So the formula here for the amount of money that you have after t years is going to be the principal, the amount you invest originally, times e to the RT. So R is 0.02 t. So the formula is being explained to us in the problem. So we have the formula there for the amount of money that you have from a $1,000 investment that's earning 2% interest. The question is, how long will it take for that to be worth $2,000? So $2,000 is an amount, which means we need the amount to be $2,000, and then we have this equation, and the question is, what is t? We can see that when it says how many years does it take, right? That's asking about a value of t. So the question is, what is t? And the amount is 2,000. So they're giving us the output of 2,000 and asking us for the input. To solve this equation, we want to isolate the exponential part. And I would do that here by just dividing both sides of this equation by 1,000. That's an exponential equation. And so I'm going to change it into a logarithmic equation. So log base e of 2 is 0.02t. Don't forget that log base e is really your natural log. And so t is going to be the natural log of 2 over 0.02, whatever that is. So you can use a calculator for that because the LN button is right under calculator. It's interesting side effect of exponential growth that the second question, how many additional years does it take for the value of the account to double again, the time will actually be the same. So that's a function of the fact that this is exponential, but you should try that and just see if you get the same answer. But regardless of what principal you start with, it'll take the same number of years for an investment to double. In this last group of problems on this page, these are problems where we're just solving exponential and logarithmic equations, and so the process is going to be very much the same as what we did here in this problem. So we're just doing it over and over and over again. In some of these, we have the nice situation where the both sides of the equation are actually exponential or logarithmic with the same base. And when that happens, we don't really have as much work to do. We can just, we know that the only way you'd get the same output is if the inputs are equal. And so, so for example, in the first problem, this is the same thing. Since 9 is 3 squared and 81 is 3 to the 4th, this is the same thing. And so if you can get the left-hand side equal to 3 to just one thing using rules of exponents, and you know that's equal to 3 to the 4th, well then you know that the two powers have to be the same and you don't have to drag logarithms into it. Similarly in part D, the inputs have to be the same here. Both the logarithmic and exponential functions have the property that the only way outputs could be equal is if the inputs are equal. And so that simplifies the problem quite a bit. In part C, for example, we don't have the opportunity to do that. So here we just use our strategy that we talked about before, which is isolate first the log or exponential that's holding your x. So in this case, by subtracting 1 from both sides and dividing by 2, I'll have log of x, natural log of x equals -6. Keep in mind that that's log base e, and so that means that e to the -6 equals x. This is an exponential equation in the same base. This is log base e. So exponential equation in the same base with the -6 switch there and the x switch there. So I've switched inputs and outputs. But in this case, that solves the problem. All right, I'll pause here and we'll do the rest of the practice problems on the next video.